Shift from EC section having roll number 04 episode. So today I want to discuss about the 8085 microprocessor. So let's get into the topic. You can find the external physical pin diagram or pin structure of a 8085 microprocessor. It has some pins on both sides. So what is microcomputer? So major components of the computer, the microprocessor, the control unit, one or more memory ICs and one or more input output ICs, and the clock. So a single printed circuit board usually connects the ICs, making a computer called microcomputer. So here you can see the structure of a microcomputer, which has input and output base and process, ALU, arithmetic logical unit and control unit, memory and clock blocks, which has data instruction, address controls, data transfer and status control. So basic architecture, printed and hardware architecture known as one human architecture, and single memory contains both the program code and data. So hardware architecture known as two separate memories, one contains only data while the other is containing only program code. So you can see the both basic architecture of printed and hardware. We already seen Winter Archer at Harvard. They both look same, but here difference occur at memory and control unit connections. So major components are processor, control unit, memory and clock. So coming to the microprocessor architecture. So what is microprocessor? A microprocessor is a multi-programmable clock driven register based semiconductor device that is used to fetch, process and execute data within fraction of seconds. So here you can see the pin configuration of 8085 microprocessor, where 12 to 19 are adding pins, and you can see the input and output pin also clock pin, data transferring pin, clock in, clock out, and VCC ground hole. So its buses, the 8085 and its buses. The 8085 is a 8-bit general purpose microprocessor that can address 64 KB of memory. So maximum is 64 KB, and it has a 40 pins, uses 5 volts per power, and it can run at maximum frequency of 3 megahertz. So the pins of the chip can be grouped into 6 groups, like address bus, data bus, control and signal status signal, control, power supply and frequency, externally initiated signals, and serial input and output ports. So these 40 pins are classified into following parts. So coming to the address and data buses, the address bus has 8 signal lines known as 8 to 850 pins, which are unidirectional, and the other address bits are multiplexer, which are time shared with 8 data bits. So the bits A0 to A7 are bidirectional and serve as A0 to A7 and D0 to D7 at the same time. So during the execution of the instruction, these lines carry the address bits during the early part. Then during the late parts of execution, they carry the 8 bits. In order to separate the address from the data, we can use a latch to save the value before the function of the bit changes. So here you can see the complete 8085 architecture, which has accumulator, temper register, flag flip-flops, ALU, timing and control units. So an instruction decoder and encoder, stack pointer, program counter, address buffer, and data address buffer, denoted A0 to A0 as we discussed earlier, and serial input and output ports, interrupt controllers. So the flags are affected by arithmetic and logical instruction, which are D7 denoted as D6 as Z, D4 as AC, and D2 as P, and D0 is CY. So It is an 8-bit what's accumulator, like it's a 8-bit register for an arithmetic and logical instruction. One of the data should be in this register, and it is used for storing the result of any arithmetic and logical manipulation. So it is also called as a register, and all the data which are sent to input and output devices are sent it via a register. So temporary register, it is used to hold the data during the operation of an arithmetic and logical operation. So sign flag. If the D7 bit of the accumulator is set, then this flag is set, that is 1, meaning that the result is negative, like 7 minus 8 equal minus 1. So carry flag, during the arithmetic operation, if a carry occurs, then flag is set. So example is f1 plus 1f equal to 1, 10. So here 1 denotes carry, and 0 flag is during the arithmetic logical operation. If the result is 0, then this flag is set, so denotes 0, 0. And parity flag, if the result is even, then the flag is set, like 0, 8 minus 0 2 equal 0, 8. And auxiliary carry flag, during BCD arithmetic operation, when a carry is generated by D3 bit and passed on to D4 bit, then this flag is set, like 1f plus 11 equal to converted to binary digit, and resulted is appear. So timing and control, it synchronizes all the operation with the clock and generate the communication between the microprocessor and peripheral. Peripheral means external connections to the microprocessor. So instruction register and decoder. This instruction is loaded in the instruction register, and the decoder decodes them and establishes the operation that has to be performed. So register, the W and Z register are temporary register used to hold the 8-bit data during the execution, and is used internally, and it is not used by the programmer. So here you can see the control and status signals divided into input and output, and S1 and S0 bits, like output fetch, memory read, memory write, input read and write, interrupt, halt, hold, reset. So arithmetic and logical unit, it's a 8-bit register. It is used for programming, performing addition, subtraction, logical operation, also and or not logical operations. And coming to the program counter, it is a 16-bit register. It is used to point out the address of the next instruction which is to be executed, and it is a stack pointer. It is a 16-bit register. It points the starting address of the stack. And BCDH and L are general purpose register, and all are 8-bit register. And if our combined as BC, D and HL, they can show 16-bit data. So this table defines the instruction calls of each parameters, like ops code, memory read, memory write, like input read and input write, where memory read has 0 input output, and S1 is 1 and S0 is 0, and memory write has similarly 0, S1 equals 0 and 1, and input and output read like 1 1 0, and input and output write 1 0 1. So interrupt act as 1 1 1, and all coming to all, it is Z 0 0, hold as ZXX, reset as ZXX. So these are the some control signal, status signal according to the bits. So here arithmetic logical units can perform 8-bit operation, like and or not, XOR, cap, and some of the logical operations. So when we look into the 8085 architecture, here serial input and output controllers as the peripheral external device, like devices, hard disk, another controllers. And coming to the interrupt controller, which helps us to stop the execution of a program through microprocessor. And the timing and control, useful to reset the process in the execution of program. And temporary register and accumulator to store the temporary values during the operation. So coming to the multiplexer, which convert the many channels into one channel. And stack pointer, which stores the operation the form of stack. So program counter counts the number of operations have been done. So I think we have brief explanation about 8085 microprocessor. Thank you.